Hello everyone. In this video, we're going to learn how to solve this math Olympiad problem. Alright, so before we're going to start, go ahead, pause the video and give you a try. Alright, let's get started. Find all real numbers x, y, z such that x squared plus y squared equals 6z. Y squared plus z squared equals 6x. Z squared plus x squared equals 6y. Alright, so this problem is a good example to illustrate a simple yet effective method for solving system of symmetric equations involving rational functions. By manipulating the given equations, one can construct a polynomial whose roots are the desired solutions. So because this is a system of symmetric equations, we have two different cases to solve this problem. The first case, at least two variables have the same values. Alright. The second case, all three variables have different values. Alright, so let's start with the first case. Case number 1. At least two are equal. Alright, so suppose x equals y. Alright, so if x equals y, we just substitute this guy into this equation. So we have 2x squared equals 6z. And then we solve for z. So z equals x squared over 3. Now we substitute this guy into the third equation right here. So we have s to the 4th over 9 plus s squared equals 6s. Now multiply both sides by 9. We have s to the 4 plus 9s squared. And then 9 times 6, it could be 54s. I subtract both sides by 54s, so it's going to be negative 54s equals 0. Alright, factor s out, so it turns out to be s cubed plus 9s minus 54 equals 0. Now next one, we're going to use the rational root theorem to factor this guy out. So by using the mental math and the rational root theorem, I can identify 3 as a solution of this guy. So I use synthetic division to factor this one. So it could be, I put 3 right here. This is coefficient in front of x cubed, it could be 1. And then 0, 9, and negative 54. Alright, I bring 1 down. 3 times 1 plus 0, it could be 3. 3 times 3 plus 9, it could be 18. 3 times 18 plus negative 54, it could be 0. Alright, so this guy turns out to be s times s minus 3 times s squared plus 3s plus 18 equals 0. Alright, this one right here, s squared plus 3s plus 18. Alright, now this guy the discriminant less than 0, so this guy has no solution. Alright, so this guy equals 0 only s equals 0, or s minus 3 equals 0, it can be s equals to 3. Alright, s equals 0, you have the first solution. Because s equals 2y right here. Alright, so it can be, first solution, it can be 0, 0. Now, substitute s equals 0 over here. So z equals 0 squared divided by 3, it can be 0. So first solution must be 0, 0, 0. And second solution, 3, 3. Now substitute 3 over here. So it can be 3 squared, it can be 9. 9 divided by 3, it can be 3. So z should be 3. So we have two solutions right here. Alright. We finished the first case. Now we're going to move on to the second case. Now case number 2. All x and y and z have different values. Alright, so if x different from y, we have x minus y must be different from 0. Y different from z, then y minus z must be different from 0. And s different from z, then s minus z should be different from 0. Alright. Now, we're going to subtract this system vertically. Alright, so I subtract the second one from the first one. So I have s squared minus z squared equals 6 parentheses z minus s. Alright, now I factor this guy, so it will be s minus z times s plus z. And then I bring this to the left hand side, so it turns out to be plus 6s minus z equals 0. Alright, I factor s minus z out, so it could be s minus z. It could be 6 plus s plus z equals 0. Now, if you do the same process, subtract the third one from the second one. So you're going to end up with y minus s times 6 plus y plus s equals 0. And if you subtract the third one from the first one, you're going to end up with y minus z times 6 plus y plus z equals 0. Alright, so you have a system of 3 equations right here. Okay. So because we have s minus y different from 0. Alright, right here. Y minus z different from 0. Y minus z right here. And s minus z different from 0. This guy right here. So then you only need to let this guy, and this guy equals 0. Alright, so you have 6 plus s plus z equals 0. 6 plus y plus s equals 0. And the last one, 6 plus y plus z equals 0. Alright. Now, Subtract this one vertically. What do we have? Now I subtract the second one from the first one. So it's going to be z minus y equals 0. Alright, subtract the third one from the second one. It's going to be s minus z equals 0. Subtract the third one from the first one. It's going to be s minus y equals 0. Alright, so it tells us that z equals y, s equals z, s equals y, which contradicts the assumption right here. So this case right here has no solution. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.